Hello guys, and welcome to another video. So on this video we'll be looking at a past paper question based on Doppler effect, starting with a multiple choice question. So here they are saying, for light, a redshift indicates the light source moves away from you, towards you, at right angles to you, parallel to you. Okay, for this one guys, we need to understand this concept of RGB, which is our light spectrum or color spectrum, if you will. We have red, we have orange, we have yellow, we have green, blue, indigo, and violet. And this is what we said, that if we are moving from red to blue or red to violet, that means increase in frequency. And if we are moving from violet to red, that means increase in wavelength. And the relationship here between frequency and wavelength is inversely proportional. And if we talk of a redshift, we said a redshift means we are moving from blue to red, right? Or can say from violet going to red. And that means we are decreasing in frequency. If we are decreasing in frequency, we are increasing in wavelength. And a decrease in frequency means that the shift is away. So the correct answer here will have to be A. The correct answer here is moving away from you. Okay, that means our light source is moving away. All right, because we said that shift means that a decrease in frequency, we are having an away type of situation. An increase in frequency means we have a towards type of situation. Done with the multiple choice. Now we look at our structured question. And our structured question is as follows. It says that a hawk emits a sound at a frequency of 90 hertz. And we have to say that, okay, I'll go there. Let's just read our statement first. So a hawk emits a sound at a frequency of 90 hertz. The speed of sound in air is taken as 340 meters per second. So this hawk, guys, is going to be our source. Okay, so this frequency here, then this frequency here will be the frequency of the source. And then they say state the Doppler effect in words. Okay, so the definition, guys, of the Doppler effect is what? We will say that it is the change in frequency or pitch of the sound detected by a listener because the sound source and the listener have different velocities relative to the medium of sound propagation. That is the definition of the Doppler effect. Okay, and remember, guys, for your exam you must know this off by your heart. You must not read it. It must be engraved inside your head. But this is how the definition is as per the exam guideline. Although there is another definition, but this one is the one that comes from the exam guideline. Now let's go to 7.2. 7.2 says a stationary observer hears the sound at 88 hertz. Is the hawk flying towards or away from the observer? So guys, what we will realize is that on our statement we've been told that the hawk had a frequency of what? 90 hertz. And here we are told that the stationary observer hears the sound at what? At 88 hertz. What does this mean? It means that our frequency has actually decreased. And if the frequency has decreased, that means actually our source is moving away from the observer. Okay, so the correct answer that we are going to go with here is that the source is actually moving away from the observer. And why are we saying this? It's because there's been a decrease in frequency. Remember, we said an increase in frequency means the source is moving towards, a decrease in frequency means the source is moving away. So the answer we choose is away from the observer. Okay, and then we go to 7.3. 7.3 says calculate the speed at which the hawk is flying. So we want to know what is the speed of the source, or the velocity of the source. In this case though, they are asking us about what? The speed. And what formula are we going to write here? But before we actually come into the matter of formula, let's write all the information that we have. We know that the frequency of the source is equal to 90 hertz, and the velocity of the source, or speed of the source, is what we want. We know that the frequency of the listener is going to be equal to 88 hertz, and we also know that this this observer is stationary, and that means their velocity is going to be 0 meters per second. We have also been told that the speed of sound, according to our statement, is what? 340 meters per second. So here we are going to write 340 meters per second. Okay, and now we are going to plug this information into our formula. The formula that we are supposed to use is FL is equal to, in brackets, V plus or minus VL divided by V plus or minus Vs, and all of this will be multiplied by the frequency of our source. And then we are going to substitute. The frequency of the listener is 88 is equal to, then on this side we know that the V represents our speed of sound, which is 340 meters per second. Then we have to now assign this, we have to choose the sign for the velocity of the listener. And remember that here our source is moving away, and if our source is moving away, that means the velocity of the listener has to be negative. The velocity of the listener will be negative, and the velocity of the source will be the opposite of this one, so it will be positive. So here we are going to have 340 minus 0 divided by 340 plus this velocity of the source, which is what we are looking for, multiplied by the frequency of the source, which is 90 hertz. And then here we are going to do the math. We know that this one is over 1, so we are multiplying numerators with each other, denominators with each other. And when we do the math here, we will have 88 is equal to what is 340 multiplied by 90? It's going to be 30,600. And then at the bottom we will have 340 plus Vs. Then from here we are now just gonna do cross multiplying, or we can multiply with this. Actually, let's multiply with the lowest common denominator, which is this. So on this side I'll multiply with, okay, which way should I do this? Okay, I'll do it this way. Let's cross multiply. We know here we have over 1, so we are multiplying like that. We are saying 30,600 times 1, it gives us 30,600, and then this 88 multiplies with this 340 and the Vs. So 88 multiplied by 340 is going to be 29,920. Okay, why am I writing it so far? It's going to be 29,920. Then 88 times Vs will be positive 88 Vs, and then we transpose this 29,920 to the other side, so it's gonna be 30,000 rather 600 minus 29,920 is equal to 88 Vs, and then we divide by the coefficient of Vs on both sides, which is 88. Here they cancel, and if we say 30,600 minus 29,920 divided by 88, the answer we get is as follows. So we'll say therefore Vs is equal to 7,73 meters per second, and that's how we get our answer, guys. So there's the full answer of us finding the velocity of the source. I hope, guys, you learned and benefited from the video. Please be kind in terms of sharing the video with your friends who are doing this subject. Also, guys, please be kind in terms of subscribing and liking the video. I'll see you on the next one, and happy learning.